Hey guys, this is Mr. C, and in this video we're going to look at solving some systems of linear equations using elimination. So generally these systems are going to be in standard form, both of them. And so elimination implies that we want to eliminate one of the variables here so that when it cancels out, then we'll have one equation with one unknown down here. So our goal is going to be to eliminate one of the variables. So one thing we can do is we can add two equations together. And so let me go ahead and show you an example of this. Let's suppose that we have an equation that says 3 plus 4 equals 7. And we all know that's going to be true. If I have another equation, then let's say I have 5 minus 1, well, let's say 5 plus 1. 5 plus 1 is equal to, that's fine, 6. If I add these two equations together, all right, here's what's going to happen. So when I add the two equations together, okay, 3 plus 5 is 8. 4 plus 1 is 5. And 7 plus 6 is 13. But 8 plus 5 is also equal to 13. And so if you add two equations together, we see that we get another equation based on the previous two, but it's also going to be true. So that's going to be my motivation for being able to do this little procedure here. And sometimes you can add the equations together right from the start, and then sometimes you have to fix them up. Let's look at these two. And what you want to do when you have this is you want to look at it and see what's going to happen if you add the two equations together immediately. If you add these two equations together, you're going to get two x's here. These are additive inverses, so they're going to cancel out, and these two constants are just going to make another number down here. So am I going to eliminate one of the variables if I, in fact, add these two equations together right from the start? And the answer to that is going to be yes, because the two y's are going to cancel out. So if I add them together, x plus x is 2x. The y's cancel out completely, so I'm not going to write anything down here because that would just be a distraction, equals, then you have a negative 15 plus 9. And so negative 15 plus 9 should give you a negative 6 when you get done there. And now we have our one equation with one unknown, and it is a one-step equation. So I just divide by 2, and I find out that x is equal to negative 3. All right. Now, like we saw in the other videos with systems of equations, it's great that we have x equal negative 3, but we also need the y value. So I need to plug that negative 3 in for an x either here or down here for this one. And it's my choice. And so I'm just going to pick the top one. So if x is negative 3, I'm going to get negative 3 plus y equals negative 15. Now that's going to give me an equation I can solve for y. And so add 3 to both sides, plus 3, and y is equal to negative 15 plus 3 is going to drop me to negative 12, and that's my y value. And now I've got the x value and I've got the y value done. And so my ordered pair then of my solution where these two lines meet is negative 3, comma, negative 12. And that's it. Sometimes you do get ones that are that easy, and then sometimes you don't. So we'll just have to look at each of these and talk about it before we start solving them. Okay, this one, what would happen if we add the two equations together right away? I'd get 2x and another one makes 3x. These two y's would cancel out because they're additive inverses, and then I get 21 over here. So it looks like I'm going to be good to go if I add the two equations together immediately. So I'm going to do that. So let's go ahead and add these two. 2x and 1 make 3. The y's cancel out, equals 14 and 7 make 21. Now there's one equation with one unknown. I divide by 3, and I get x is equal to 7. Okay, so that's my x value. And now I have to find my y value. So I got to plug that x value in somewhere. And so let's plug it in. Let's just say, I don't know, here. It doesn't really matter. Okay, so 2 times 7, because x is 7, minus y is equal to 14. So we have now 14 minus y is equal to 14. Interesting, if I subtract 14 from both sides, both of them cancel and I get negative y is equal to 0. Now, if I divide by negative 1, I'm still going to get y is equal to 0 because 0 divided by negative 1 is still 0. And so this one, the y coordinate of the point where the two lines meet is going to be 0. And so my solution is 7, 0. So that's it for that one. All right, let's take a look at this one. Okay, this one, I'm looking at, if I add them together, I'm going to get an 8x here, I'm going to get a negative 2y there. It's not going to really do me any good to add them together right away because nothing cancels out. However, if I multiply that by 2, I'll get a negative 4, I'll get a 4 up here. Then they would cancel. So it's kind of like playing a game of chess. You have to think ahead one move and know that that one move is going to help you out. So what I'm going to do is I'm going to multiply this equation by 2. And this is something you can do because when you multiply everything by 2, it's the same exact line. We've talked about it. And you could also divide everything by 2 to get rid of it if you didn't want it. So we're going to multiply everything by 2. So 6x, okay, 2 times 2 would be plus 4y equals, and then we can't forget the constant, negative 4 times 2 is negative 8. Now the bottom one, we're going to leave that one alone because now I have what I need. And now the 4y's are going to cancel out because they're additive inverses. These are not, but these are. So now I'm going to go over here and I'm going to add these two equations together. Now when you're solving systems of equations like this, it does get kind of messy and it goes all over the place. So, don't freak out if that happens. It's very common. So 6x and 5x makes 11x. 4y and negative 4y cancel out. And negative 8 and 8 make 0. So I divide by 11, and it turns out that x is equal to 0 divided by 11 is 0. So in this case, the x coordinate of the solution, the point where they meet, the lines, is 0. All right. To get my corresponding y value, I'm going to plug that 0 back in, and let's plug it in up here, right there in the top one. So we have 3 times 0 plus 2y equals negative 4. Because that's the only way to get the y value. You got to plug the x value back in once you know what it is. So I got 0 plus 2y equals negative 4. Well, the 0 doesn't do anything, so it just goes away. So 2y is equal to negative 4. Divide by 2, and y is equal to negative 4 divided by 2 is negative 2. So now I have the x and y value I need, and it's going to be 0, negative 2. You could plug those coordinates in for x and y up here in each equation just to make sure you get a true statement here and a true statement there. So if this was a test or a quiz, I would probably do that. All right, next one. Let's take a look at this. These are not inverses. These are not additive inverses. Nothing's going to cancel. So this is kind of bad. However, I do see that 3 could be canceled with this if it was a 6. So if I multiply that by 2, in fact, negative 2, they would cancel. So I'm going to multiply this whole equation by negative 2 on the bottom. So the top one is going to stay. I mean, why would I multiply that by anything? I got the 6x I want. But down here, I'm going to get negative 6x. Then I'm going to get a positive 4y. And you have to be very careful now when you do this. And a negative 4 as my constant. Okay, now the x's will cancel this time. I can add them together now. These go away. Negative 5 and 4 make negative 1y equals negative 1 plus negative 4 is actually negative 5. So now if I divide by negative 1, those cancel, and y is equal to positive 5. So I found my y value. Now I need to plug it back in to get my x value. So I don't know, let's plug it in. It doesn't really matter where you plug it into. We'll plug it in the top one again, just to keep it constant. The same thing we've been doing. All right, so we have 6x minus 5 times 5 equals -1. So we have 6x minus 25 equals -1. So if we add 25 to both sides, plus 25, those cancel. 6x is equal to 25, take away 1 is 24. Divide by 6, divide by 6, and x is equal to, looks like 4, right? So now I know that x is 4 and y is 5, and my solution is 4, 5 on the coordinate plane. That's where those two lines would meet. All right, let's try this one. This one, 7 and 2, they have nothing in common, both prime. 5 and 3, nothing in common, both prime. So now I have a problem, and my problem is I need to fix up both equations. This is the worst possible scenario. Generally not going to get any worse than this. All right, we got to fix up both of them. So elimination, you have to choose a variable to eliminate. I'm going to choose the y's because they already have opposite signs, and I don't have to fool with any negatives. So you could eliminate the x's if you want to, but I'm going to choose the y's. So I'm going to multiply this guy by 3, and I'm going to multiply this guy by 5. So if I do that, I'm going to get a -15 here and a +15 there, and then they will cancel. So that's my goal. I don't care about this. I don't care about this. I want those to cancel. So let's see if they're going to. Okay, we've got 21x minus 15y equals 3 times 3 is 9. All right, down here we got 10x. We got a +15y equals, and it's very common for these numbers to get big. 8 times 5 is 40, so -40. And you just have to be very, very careful about your negatives and positives there. All right, now let's go over here and let's go ahead and add those two equations together to get another one. 21 and 10 make 31, so 31x. Those cancel, equals 9 minus 40, I believe, is going to be -31. So that's very, very good. We're going to divide by 31. And it looks like x is going to be equal to -1. And there's my x value. Okay. So the most common mistake are people, they forget to distribute these numbers to everything, and then when they distribute them wrong, or they mess up their negatives and positives. Very common. So just keep track of what you're doing. So x is -1. Let's go ahead and put that right here. -1 in the bottom one this time. All right, so we got 2 times -1 plus 3 times y, we don't know what y is, equals -8. All right, so we got -2 plus 3y equals -8. Now we're going to add 2 to both sides. Bring down my 3y equals -6, right? Divide by 3, divide by 3, and it looks like my y value is -2. So it's looking like these two lines are going to meet at -1, -2. So that looks like the solution of those two. All right, a couple more. What else can happen? Well, let's take a look at this one. Okay, this one, if I look at the two equations and I think, well, I really want to get rid of that. I really want to get rid of the x's this time. All right, so let's just decide, well, I want to get rid of the x's. So this one, I want to be a 6, and then, as a matter of fact, I want it to be a -6 there. So what times 2 is -6? And we see that it's -3. So if I distribute that -3 to everything up here, I'm going to get -6x. So -6x. I'm going to get +9y equals -18. Now my bottom equation is 6x minus 9y equals 18. Nothing happened there because I didn't want to change that 6. I just wanted to make that a negative 6, and I did it. So now let's take a look and let's see what happens. If I now add the two equations together, and you might be looking at this going, uh-oh, something bad's about to happen. These two guys cancel. These two guys cancel. The entire left-hand side cancels, and it makes 0. The right side cancels, and it makes 0. So now all the variables canceled, and I get a true statement. This right here is true because 0 does equal 0. If that happens, then what that means is one equation is a multiple of the other one, which means they are the same line. And if you were to graph those two lines, they would completely overlap. And so what now do you say as your solution? Well, what happens is that any XY pair is going to be a solution to both of these. If it's a solution to one, it'll be a solution of the other one. So there are infinitely many solutions. I don't like to use the term all real numbers because if I say all real numbers, that's not exactly true for this because each solution is an ordered pair, not just a real number. So infinitely many solutions just means, hey, anything that's a solution to one is going to be a solution of the other one. And so I'm not getting any new information there. So there are infinitely many solutions for that one. All right, so let's take a look at this one and see how this one's going to work. And again, we're going to use elimination. So let's say, again, I want to get rid of the x again, get rid of the x's. So I'm going to multiply the top one by -4, and then I'll get -4x and +4x, and they'll cancel. All right, so I got a -4x coming up here, -4x. I got a -8y, so -8y equals, and that would be a +20, so 20. Now, the bottom one stays the same. 4x plus 8y equals +20. So now, we're going to go ahead and add those two equations together and see what happens. So, let's see what happens this time. And you might think, well, the same thing's going to happen. Cancel, cancel. So 0 equals. And can't tell you how many students I've seen will put a 0 right there. However, 20 plus 20 is definitely 40. Okay, so that's a little trick there. So what happens? You got 0 is equal to 40. Is that true? No, that is false. That is a false statement. So if you get a false statement, what that means is the two lines are parallel. They have the same slope, but they have a different y-intercept. And so those are parallel, and your answer to this would be no solution. Or you can put the empty set down symbol. So that's basically how to solve these systems of equations using elimination. Feel free to look at this video as much as you want, pause it as you're solving some other problems, use it as a guide or an example. And remember to like and share the video, subscribe to my channel if you haven't already, and we'll see you guys later. Bye.